Assalamualaikum and hi. So today our group Equivalence Squad will be present to you about properties of relation. So before we continue to our presentation, I will introduce to you to our group members. So my name is INSYIRAH binti SHAHBANI and I'm the project manager where my scope job is to develop a project plan, manage deliverables according to the plan that has been made and then assign tasks to the team members. And then Muhammad LUQMAN bin KHUSAIRI as the programmer where his scope job is to write the code and design user interface of the system. And then NURUL NAJIHAH ADLI as the program designer where her scope job is to work on the develop phase such as flowchart or procedural code of the system. And last but not least, my project analyst AYUNI binti Cikgu Muhammad JAILANI where her scope is to help me to plan, organize and execute the project and making some analysis to the project. I will start the presentation by telling the introduction to our project title. So our group project in discrete structure CSE 510 chose the title of properties of relation, which is question 2 that specifically focus about reflexive, symmetry and transitive properties as well as their closure. So our purpose is to develop a Java program that using Eclipse that determines whether a given relation meets these properties and generates their closure if needed. So a binary relation R from set A to set B is a subset of the Cartesian product A by B, where R, A, B means A is related to B. So, a relation is reflexive if every element in A is related to itself. For example, AA, BB, CC. And then symmetry will be happen if ARB implies BRA. For example, in the relation, they have AB and BA. And last but not least, transitive if ARB and BRC imply ARC, meaning that in the relation, they have AB and BC. When they combine, it will be AC. So AC needed to have in the relation. If a relation is satisfy all three properties, it is called an equivalent relation. So our program will serve as a practical tool to analyze relation and compute their closure based on these properties. Next is the problem statement. The study of relation properties is the fundamental part of mathematics and computer science, but students nowadays often struggle to identify these properties under specific conditions accurately. So by using the manual analysis that is straightforward, it can also be error-prone that leads to incorrect conclusion and hindering the learning process, especially when determining multiple properties at once. So to solve the problems, we create a program that offers a practical solution, where this tool allows user to input the numbers of pair and insert the pair in themselves. Automatically evaluate the relation properties based on the predefined rules. By minimizing the error and improving the accuracy, the program enhances understanding and makes learning about relational properties more efficient and effective for the students.
Okay, Assalamualaikum. My name is Muhammad LUQMAN bin KHUSAIRI and I will be explaining our interface of the system, the programming code, and then of course I will be doing a small demonstration of our system. So let's get to it. So this is our interface of the system. These are where the system asks the user to enter the number of pairs, and then the user are also required to enter the number of the numbers, which is right here, which is of course separated by space to easily be put in our system. Okay, now I'll be doing a little demonstration of our system. So on top of me here, which is a question from a final test of 2022 October. And the questions ask where to check the condition, the properties relation of the set, which is the R. And so we'll be using our system to do that. So as you can see here, the system has 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pairs in the set. So we entered 9, and then we entered the pairs, of course separated by space. So 0, 1, 0, 2, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 2, and 3, 3. And after we entered all the pairs in the set, we hit enter, and then we'll check check the properties of relation. As you can see here, the relation is a reflexive but not transitive and symmetric. And of course, it will display the closure here. For reflexive closure, there's no closure right here as it is a reflexive. For transitive, it's missing 1 pairs, which is a 2, 1. And then for the symmetric, same thing, it's missing 2, 1. So to answer the question, for the first question, it is a reflexive. For the second question, it is not symmetric. And in the third question, it is not transitive. Now to answer the question, is R an equivalence relation? If so, why? R is not an equivalence relation as it is not symmetric and transitive. And of course, I have the answer here prepared right here. For question 1, it is a reflexive. For the question 2, it is not symmetric. And then for question 3, it is not transitive. And then for question 4, right here, No, because R is not symmetric and not transitive. So this shows that our system works perfectly fine. And so yeah, that is all for our little demonstration. And thank you. Next, this is our programming code. On the left is the first half of it, and then on the right is the second half of it. This is basically the our heart of the system, where it will check the properties of relation for the set entered by the users and will also generate the respective closure.
So next is the algorithm of systems. It represents process for checking and analyzing properties of the relation on a set. So first we start, which is the process reading, and then next we input the number of pair, and after that we enter element for the relation, and we check if the number element is matched with the number of pair, so it will proceed. If not, user must enter another more element. So if the number of element and number of pair is matched, so it will proceed. So it we convert set to list and then display the sorted element. After we display the sorted element, we check the reflexive. If the relation contain all pair for every number in the set, so it will display reflexive and reflexive closure will be null. If not, it will display not reflexive and then print the reflexive closure. And then next we check the transitive. If the relation is transitive, so it will display transitive and transitive closure will be null. If not, not transitive and it will print the closure. And next, we check the symmetry. If for every number is pair, which is for example AB, pair with BA, so also exists and the relation is symmetric and it will display symmetric and then the symmetric closure will be null. If not, it will display not symmetric and then the closure will be free. And after checking all the properties, we will display the final closure of the relation. So after that, the process will be end and terminate. So that's all.
My name is AYUNI binti Cikgu Muhammad JAILANI. For our program testimony, we already initialized 3 different input for the element offset, which is for the first case, set S is equals to 32, 23, 11. From our program checking, this input for set S produce neither reflexive nor transitive relation. However, this set has symmetry relations, so for the closure, only reflexive and transitive closure has been displayed, where for reflexive closure, the elements is 22 and 33. Meanwhile, for transitive closure, it is 33 and 22. Next, for the case 2, we initialize S as 11, 22, and 12. Then, for this case, symmetric relation did not satisfy, where it leads to closure to be displayed, where the closure element is 21. Lastly, for our last case, input is 11, 22, 12, and 21 did satisfy all of the conditions for all of the relation types. So, since all of the properties is satisfied, no closure has been displayed for all relation. Next, for our program limitation, one of the key issues is efficiency. When dealing with a large number of elements, the system may struggle to process them efficiently. This can lead to confusion during input initialization and property analysis. For example, when too many elements are involved, it becomes too difficult to track, organize, and analyze each of the element efficiently and effectively, and it will lead to delay and possible errors. Another challenge is a larger memory space is required to store all of the data, which can put a strain on the system resources. Additionally, since more data needs to be processed, the time taken to check and verify all of the properties of these elements also increases. This can slow down the overall performance and make the program less responsive. In conclusion, this project has significantly deepened our understanding of relational properties, which is allowing us to see how theoretical concepts are applied in practical scenarios. It has also sharpened our critical thinking skills as we tackle challenges and sought innovative solutions to implement our knowledge effectively in the program. Additionally, working on this project has strengthened our proficiency in using Java compiler, encouraging us to explore Java syntax more extensively and improving our overall coding abilities. Also, throughout these processes, we encountered both challenges and achievements, each contributing to rich learning experiences that has enhanced our problem-solving skills, teamwork, and confidence in programming. This project has been an insightful and rewarding journey, equipping us with both technical expertise and valuable experiences that will benefit us in the futures endeavors. So that's all from us. Thank you for listening.